Hi, this is Rajneesh, and I'm recording this session uh, to demo deploying a backend app on Kubernetes cluster, where I'll be deploying a backend app, database, uh, and both will be communicating internally, while my backend API would be accessible from external internet. So I just created this cluster. Uh, uh, mm, I tried creating this cluster before starting the recording because it is a time-taking step. So if we could find out from the details when this was created, uh, we see this message as well. Like this was created right now only, yeah, 2 minutes ago. So my cluster is ready. Now I have created this cluster with 3 nodes. And also I have provisioned a 50 GB storage here. So if I could show you where do I find the storage details for this? Uh, look at back. This is my cluster. This is ready. I go here. Uh, where do I find the? Okay, so I have the storage available here, but okay, there's some error. Mm, yeah, but while setting up, we configured to provision a 50 GB of storage. So yeah, I'm just showing this so that we won't be configuring a separate persistent storage while deploying the database. I'll be using the same thing. So mm, where can I find that information? If not, maybe we'll continue. So first I'll move to my source code. Here I have created this product app. This is the Node.js based application. So to run this locally, you can follow these commands. Then you have to run through a Docker. You have this command. If I go through the code, so these are the default files. Uh, I'll later go to the Docker file. First, I have this folder structure. So uh, all these files have a very little code. Like index.js is my setup and all the endpoints done here. Then I have the routes. I just have a products route where I can get products. I can search them. I can get by category or I can get by ID. So, and then I have some loggers added here. So let's do one thing. Uh, hmm. So what I'll do is, yeah, so on uh, my current machine, I do not have Docker setup done. So what I'll do is I'll go back here, then to compute, I have a VM instance running here, and this is my instance. Though this one, I think these are the nodes which I just created. So I'll connect to this through this switch, and yeah, so this is the same VM instance that we had done set up for while the session demos. So I've kept this just that I can use this to build my Docker image and then push it to dockerHub. So if I get the current directory, I have this demo app which we had created during this session demo. Now, if I do a Docker, image. I think we should be Docker image. Yeah. So we have these images available already. So now what we'll do is we'll go to top GitHub. What I'll do is I'll try to pull this repo to my VM. So I'll use this git clone and this thing here. Now this is done. Now if I do ls here, I have the product app available here. I'll move to product app and then I'll do a directory list here. So I have my Docker file available here. Uh, Again, I can go to my GitHub. I can open this Docker file and we just have some basic steps. So I have uh, requested for node, then the working directory would be application. What needs to be copied is package and package log.json to the current directory. And so from the source code, you'll see at the root level, we have package and package log.json. That is the only required files we need to run this application. Then from the app directory, I've copied everything inside /app. Okay. And then we have exposed this port. And then finally, we have this node command, which is available, which will run basically index.js from app directory, which is available here, this file. Fine. So I have my um, this thing here, source code available on my VM. Now what I'll do is I'll try to build this image. So I'll use help of my I think this command. So this is docker build, and then we'll use -t for tagging this. Now then I'll name. So let's say I'll call this product app, and then we'll do a versioning. So version 1.0 and to the current directory. Okay. So let's run this command. Now this is building my image. So now this is installing the dependencies and done. Now if I do a clear here and if I do a Docker image ls again, then I have a product app available. See, now this image is created with version 1.0. Now I can run this image as well. So what is the command? It is docker run. I think we need to export the port 3000 to 80, and then I have image name dot app v1.0. Is this the right command? Yeah. So see, our application is running. Product API is started on port 3000. So yeah, this is running, and so this looks fine. We have correct image ready. So let me close this, and again we'll do a clear. Fine. Now next step is to push this image to dockerHub. So we'll have this hub.docker.com. Yeah, currently I just have a one public repo that is demo app. Now we'll go to my Vim, and as I just showed, I have this image ready. What I'll do is I'll do a tagging of image. So Docker tag and image name is product app, and then my username is so so 7 product app follow 1.0. Okay, let's run this command. Okay, so the image name would be name added with the tag. So yeah, so this should be running fine. Yeah. Now if I do a Docker image, now I have this repository ready. Okay. Now again this has, so what we'll do is we'll just do a Docker push and image name. So Docker push and change 07. Then we have a product app and this. Does this work? Yeah, looks like we have pushed the image to Docker Hub. We'll do a refresh here. Yes, it is available here. Now the V1 version is available, and then we'll be able to see the Docker file content here. Fine. So image is built, pushed to Docker Hub now. So what do we need now? It is available on Docker Hub. Now, uh, yeah. So what we'll do is we'll just do a backtrack and we'll start deploying our database first, and then we'll see the things running, and then finally we'll deploy the backend app from Docker Hub to the Kubernetes cluster. So cluster I have already shown you, it is running ready here. Now what we'll do is we'll go here to Kubernetes engine. We have this, do we have, yeah, we have this clusters. Now we'll go inside this cluster and we'll open this connect. We'll copy this, we'll minimize this for a while. Now I'll open this. I have already installed gcloud and kubectl CLIs, so I'll be able to run those. Now uh, the command which we copied from there, I'll paste it here and run it. Yeah, so it says kube config entry generated for cluster 1. I can do kubectl config view, and it is ready here. Fine. Uh, that kube config uh, has been generated. So what we'll do is we'll start from the database deployment first. So on my local machine, I have this folder, DevOps Learning. Now, this is my source code that is already available on GitHub. I have this folder for database deployment. So we'll start from, let's open all these files. Okay, I'll open them all. So that we can see the content. Now, as I said, we'll go step by step. So I'll create a namespace first, and what this will do is uh, this will kind of create a folder, mm, like virtual folder on my cluster, so that I can group all my deployment, like related things to this deployment. I can categorize them. So this could be optional, but let's do this to categorize our deployment files and uh, elements, whatever will be created from this deployment. So I'll do a desktop, then we have a learning folder, then we have a DevOps learning, then we have a database. Okay, we're inside the database folder. I have all my files listed here. So what I'll do is kubectl apply, then file namespace.yaml. Now I would I should have uh, opened my lens before running this to show you um the creation of it, but no worries. Like we have few more things to show. So now I won't be opening lens in a default way because it is having some problem while reading the environment variable. So I have found a command to open my lens from a command line. So I'll paste this, and this will open my lens. Okay, so I'll minimize this. Cool. Uh, so we have a command running here, and we have lens also running. Now we have VS Code. So I've showed you what namespace we have created. We'll see this is cluster one that we are working on. This is being connected. Now this is ready. So I'll go to namespace, and this is product app namespace we just created. It says 93 seconds is the age. Cool. So we have created the namespace. Now we'll move to creating the secret. Uh, so this is the YAML we have written for this. We have named it and Postgres secret. We have used some label. Now we have this credentials here that is base 64 encoded. So it's just some basic credentials I've used, not very complex, but just to demo that we will be using this secret that will be fetched by the uh, stateful set, right, while deploying the database, running it. So this is my secret file. Now I can go back here. I'll Now we have created this namespace. So maybe I'll show you here that inside config we do not have any secret to product app. Yeah. Now once I run this file, that is Postgres secret.yaml. So it says secret is created. Now see, this is available here, and I have this DB password user. All things are available here. Cool. Now next step is we're creating the config map. So I have used this query to initialize the data base table uh, so that we do not have to do the insertion and all things. This will be run only once while the pod is being initialized. not pod, basically the stateful set, and it will create the database and tables, and every pod, uh, let's say like after this, like once destroyed and recreated, like number of pods whichever will be utilized by the deployment, they will be getting the same name and they'll be referring the same database. So we'll run this init config, and so let's do this. Uh, Postgres, it is init config map.yaml. So we have it's just a config map only. Like we have other things also here available here. So what does this say? It says config map created. If I go here inside product app namespace, we have this thing created, and this we have this query stored here. And the other things are loaded here, and then we have the query which we have wrote in that YAML file. Fine. So we have created the secret namespace and config map. Now we'll need to create a storage class that will be referred by the persistent volume claim. So I'm not creating any storage, but I have to create a storage class. I'll be referring the storage from my cluster. So what I'll do is let's create a storage class. Storage class.yaml, and storage class is created. So go here, storage classes. We have created Postgres SSD because 30 seconds ago, yeah, policy is retained, right? So it even if the pods are destroyed, like it will be retained and our data won't be lost. So now the next step will be creating the PVC, that is persistent volume claim. So Postgres pvc.yaml. If we see the content of the file, it says it is kind persistent volume claim name. It has namespace again referring to product app. Access mode is read write once. So is class name, and then it is requesting a storage of 20 GB. So if I run this, yeah, so there should be a persistent volume claim created inside product app. It is said storage size of 20 GB. Now this is about to be ready. So cool. Storage class, we have created a correct PVC product app and still pending. So it may take some time to get ready. Let's just see. So we have namespace correct, annotations, we have access mode is correct, storage is correct, and class name is correct. Persistent volume claim. So I think we should move to create a stateful set deployment because it so now stateful set deployment is basically what it differs from this normal deployment kind is like if you are using a normal deployment type, it will lose all your data. Like it, everything will be lost once the pods are destroyed. And if a new pods created, uh, it will basically uh, get its own IP address, its own data and all. Right? It is kind of reset to zero. So here what we're doing is like we are creating a headless. Not here basically. We'll be doing this here. But we're creating a deployment for stateful set so that our data, whatever we have in our applications, will be persisted and should not be lost. Now, again, if you see here, it is saying that it will be running that init.sql query. So what I'll do is I'll do this and stateful. Stateful set, yeah. So I'll be doing a stateful set deployment here. Now, yeah. So it says done. So I should be able to see some pods now. Yeah, see here. So our database thing is getting deployed. It is controlled by stateful set, as I said, and it is up and running now. So persistent volume claim is bound. Storage class. Yeah, so everything is ready now. It has a capacity of 20 GB and it is bound. So everything seems ready now. Now we need to make a way so that it can communicate with other elements in the cluster, like other nodes, or not to the external internet, but internally it should be able to communicate with other nodes. So we need to create a service, headless and config IP. So what we'll be doing is we'll be running this YAML file services.yaml, and what it is doing here is it is creating a headless service uh, that is it does not have any cluster IP, so no communication. Basically, its job is to assign some DNS name to the pod and not the IP. So every time the pod will be destroyed and new one will be created, it will have its own new IP, but it will be bound to the same DNS. So that every time someone refers to that DNS, they'll be redirected to the up and running pod. Now we have another thing that is cluster IP here, and then it has this port thing. So this will be used to communicate internally with other nodes. So we'll go here, we'll run this service, and at this moment there shouldn't be any services ready. Yeah, okay. I think it created quickly. So we have a headless service and we have a service here. So it has a cluster IP none, and then this is having this cluster IP used to communicate between nodes and ports. It does not have external IP, so there's no communication possible from the external internet. Yeah, so the database is ready and it's deployed. Now it needs to be consumed by our application deployment. So we have seen the services, we have seen the pods running. It is running a single pod only right now. So we can do that pod auto scaling and uh, the other things. Currently, I've done it for the backend application, but we can manage things here. Now, yeah, so there's no way we can test this database. Uh, I think uh, we can just see things running here. Fine. Let's do the application deployment and we'll test the functionality here. So my image was, I'll clear this. My image was deployed, not deployed, pushed to dockerHub. So it is ready to be pulled. So now what I'll do is I'll go to my directory here. Uh, product app is here. My API service, API deployment. Uh, it will need the image. So I was testing this. Uh, I have already set this, so I think it should be running fine. Fine. So we'll close this. We'll again so again we are creating a config map here. The content is like we have a config map, we have a DB host port, uh, the application port K8s, API version or environment production. I just set it to production. Now we have this API deployment. It is a normal deployment. We did a stateful set deployment for database. Now we are doing a deployment for our backend app. Now we have two replicas. Uh, Again, it will be referring the same namespace. Service tier rolling update. We are using rolling update here. And see, we have this thing here. Uh, uh, Basically, the start like to add a node and remove node. Like we'll be hitting this health endpoint, and uh, if there are 12 failures, right, we'll be doing things like this is the resource request for each like while doing the HPA thing, and this is to check if the database is ready. Then this is to auto scale the pods. Uh, hmm, Fine. This is product API containers. We have named it product API. So what we'll do is we'll go here and we'll run this thing so that our application is also ready. So we just have one pod running now. Now in that deployment we saw we will be having just a second. Yeah, we'll be having minimum two pods for the backend application. So I'm in the right directory. I was just checking. Now I'll do kubectl apply file path and I'll say API config map.yaml. Now, last time I showed you there was config maps. In the products app, we just had one config map created for the database. If I run this now, yeah, config map created, and do I need a refresh here or what? So config maps. API config is created. Yeah, yeah. API config is created, and I can go here. I can see the values here. Cool. Config map created. Now we'll go and we'll create a deployment. So, okay. So we'll create a deployment. This will make our pods ready. So deployment is created. We'll go here. We'll see uh, product API. Okay. And it is unavailable because the services are not created. These are running. Okay. The pods are created. Minimum two pods are created. This is deployment we just created. It is running now. And pods are also running. This one is for database. This is for our backend application. Now to communicate, we'll be needing the services thing ready. So we'll create a service so that this can communicate, and the service will be of type load balancer. Yeah, so load balancers so that it can communicate to the external internet, and then it can redirect the traffic to the available pods and maybe handle the communication easily. So we'll create this service of type load balancer. Cool. So service is created, and if I go here, see, yeah, so product API services is pending, and okay, so I'm just waiting for this to get ready. And if you notice, like this has been deployed, or you say it is ready now. Now we get a external IP, not for the other two which we deployed for the database, but we have this uh, external IP because we use that load balancer type service. Now, if we copy this, we need to do few more things, but at this stage, if I go and access this, uh, it may not work because we are on HTTPS. If I go on HTTP, you see that we have our backend application deployed. It says it is the product API version. This is this, uptime is this, and endpoints with this. Now I can do a ready endpoint hit, and it says database is ready. Also, I can do a health check, and it says status okay. Cool. So finally, let's just do a products, I think. Yeah. So we have been able to get the products. Now, this content is available in the pod deployed for the database, and this communication is happening internally between the backend application pod and the database thing. Right? We can only access this application and not the database. If it should be working. Yeah, I am able to get the product with ID1. Cool. So the API has been deployed and it is working fine. What else we need to do? So at this moment, we just have done a normal deployment, and to add more um, availability, you can say on top of it, we can use HPA, like uh, horizontal pod auto scaler thing, so that if there is anything wrong, right? And if we want to maintain a minimum and maximum of pods running, right? We can use a horizontal pod out scalar thing. So we have kind of horizontal pod out scalar at minimum replication replicas should be running 2, max should be 10, right? And then uh, we have a behavior defined for scale up and scale down. So uh, like we must have written some condition. I think it was in the deployment, but uh, it can scale down to mm, it can it can scale maximum of one pods within a period of 60 seconds, right? And then we have a scale up behavior defined, right? Now, yeah, metrics we have defined here. So if the CPU utilization is 60% or above, uh, and or maybe memory utilization is beyond 70 or 70%, like the like 70 or more than 70%. So in that case, this horizontal pod auto scaler should be running. So I can like maybe or maybe before that should we see the auto healing, like so if I delete this, right, a new pod has been started. See, so if any of the pod gets lost, like uh, so a new will be created and minimum of two will be maintained like we have defined in the deployment. Same we have maintained here, like we can probably say three, and let's just do this. Like we'll do three, and so HPA. So we'll notice this thing. We're here, and it is created, right? So what if I go to overview and then come back to pods? Okay, HPA is not running because probably we have not uh, hit that condition, like right. So we have a deployment here. It says two pods should be running, like two replicas should be running. Um, we have three nodes. Let's define there. PDB we have not configured. I'll maybe do this next, or maybe we can leave this. But I have created a script for PDB as well. But where can we find this? Metrics, it's just unknown. Okay, currently it says unknown, both the things. Maybe what should we do? Should we go here and start hitting it? So I'm doing some quick refreshes here, and we'll come back and we'll see has it changed or not. So this is unable to get the CPU utilization for this, but what if I delete this? Now, what is this? So we have two running and one got terminated. Okay, fine. So there were minimum three, like while deleting it, and one got created, one was in process of deleting it. Then deployment says it should minimum replicas running should be two. So yeah, so our application is ready. We are able to access the database, and yeah, uh, we have we have this configuration written here. Like it says always have one pod running. Like we have just written some basic configuration, not very complex for PDB, but um, yeah, it says kindness product pod disruption budget. So if there is any pod getting destroyed and created, we'll have to maintain minimum of one. But I'm not running this because not required for demo. So yeah, I was able to create this, and let's do this as well. Like it is, it has the name of Postgres 0. See, yeah, maybe I'll show this as well. So it has a pod which has been given a name of Postgres 0. If you go to deployments, the deployments services, maybe, yeah. So, yeah, let's do this. We'll destroy the database pod. Okay, I'm deleting the database pod here, and it is again created. And if you see the time when we destroyed this pod, it got a new ID, but it is getting the same name. Basically, name here is combination of the the name given in the YAML plus some ID. But here for the database, it is getting the same name. Every time a pod will be destroyed and created, you will be seeing the same name, and this is being done by this stateful set deployment. Okay, so as we deleted the database, but are we still able to access this product? We are, right? We can. If I go and change the endpoint and hit this, see we are still able to get the we're still able to get the records, right? So nothing was lost, even though our pods was deleted. Cool. So this completes our session. Uh, uh, yeah. Next is like mm, yeah. I think we can now delete those. So yeah, I have my source code here. Mm, We have this image available on the repositories. Good. So yeah, thank you.